Hello.
Hello.
Hi, how are you?
Assalamu alaikum. How are you, Zia bhai? I'm good.
Wonderful. Good. So basically, I have a data set here. It's pulmonary embolism data set. This is a data set that we basically took from this data set, which is basically all years data set from 2002 to 2019. This is a modified data set of NIS. It's heavily modified. It's kind of been condensed, changed, and multiple years been smushed together so we can get a single data set. So the way we kind of get data sets separated is simply using select cases, then putting information here. If you want to kind of select PE cases, you just do PE is equal to 1. And then you copy database and name it something else. And then you just click OK, separate data file is created. Data elements, basically, most of them are pretty much self-explanatory on the label side. You can pretty much see everything on the label side. The one that are not really explained are these variables, but you can kind of deduce what they really mean by looking at the either at the values or at the labels. Like you get an idea what they really mean. Then these are also self-explanatory, basically. Hypertension, HIV, metastatic cancer. But if you have any questions on these, you can always ask me. If you look at my older papers, any of the papers, let's see if you go to TAVR papers, what I usually do is do like literature review and then try to figure out which variables do I need to use. It really depends upon case to case. So in PE, you might want to use prior history of atrial fibrillation, prior history of peripheral vascular disease, renal failure, liver disease, because all of these actually predisposes to higher clots. Smoking.
Right.
So you have to kind of do your own literature review and figure out which variables you want. Once you find out, then you just create a simple table. Obviously, age, sex, race, hospital size, most of the time insurance, that's a good thing to look at but these things are universal, but the comorbidities you have to do different from case to case. Once you do chi-square through tables, that would be your unmatched data. Then you can do propensity matching. You don't need to do propensity matching all the time. It's done in very special cases. You can simply do a regression predictors of mortality. And basically, to do tables, I think it's pretty straightforward, but you use the custom tables menu. And to use medians, you just go to explore and you create your medians from here. Once you do that, then the regression part is a bit complicated. So the concept of regression is to kind of draw a line on a scattered plot that would fit a particular pattern. Normally we do a linear regression, meaning a linear line, but it can be a log and multiple scales, but normally it's a linear regression. Now, whenever you do regression, there are two ways to look at it. One is a mathematical approach. So most of the time statisticians in different journals will ask you what was your criteria to select variables for regression. That will mostly be, you do a bivariate analysis and you get kind of, so this is a bivariate analysis and you kind of get a correlation. Let's say we just do a correlation between these three variables, but your correlation is going to be like between the variable of interest and the other variables. To create a correlation, let's see this, let's hope this is fast. The data set is a bit big, but so when you run a correlation, you get an association and then you get a p-value. So
Right.
p-value is depend upon data set size. Association doesn't really depend upon data set size. So you kind of can preset what is the amount of association you want. You can say, okay, if it's 0.1, I'm going to select those variables. And then you just put those variables in regression.
Mhm.
One way to go through it. And that's what most of the statisticians would like because they're mathematicians, basically. But you can also look at it in a different way. You can say, hey, I know that smoking is important, so I don't care what's the association. I know this is clinically relevant, so I'm going to use these variables. That's the second approach you can do.
Right.
I mostly do bivariate. I think I've touched upon that in some lecture before, but if that's something confusing, just let me know. This data set is too big for me to, I'll probably
Mhm.
make a smaller data set and show it to you. Then finally, how I make, once I get regression values, I put them in R actually, because R you can do plots. There are different packages in R, but usually you can put, R is basically you put a formula and it does stuff for you. So this is like typical R. It's just like from old days, like Microsoft DOS kind of. So first I set the data file, like where I want to do my, you can either do it from here or you can just browse on here and just go to the file folder where you want to, where's your data is presently present. Once you go to that data location, you can just click, right click here, sorry, right click, set as working directory. Once you do that, then you have to go through a fixed thing. First, you recall your whatever package you want to use. So here I want to use a ggplot2 package. So I write library ggplot2. So it's recalled. Then I kind of name the data file. Probably have to do it one by one, otherwise you won't understand. But maybe I'll run through this. But this is how I used to make the regression plot. It's
Mhm.
basically R. So let's run through one case. So we can then do this. So here I have TAVR and stage renal disease. I'm going to make, I just browsed here. This is where my data set is. I just make this as set as working directory. Then I have already saved, I've copy pasted the regression. Let's do a quick regression on a smaller file. So this is a much smaller data set. So let's run that. So we want to do a quick regression. After bivariate, we choose our variables. We want to do a regression of, let's say, what's the let's see. So what are the predictors of mortality? Let's do that regression. So death is our dependent variable which we want to check, and let's just do 3 variables like race. We can do COPD, and then we can do renal failure. You go to categorical, you just decide whether these variables are categorical, all of them are, then you change to first. Basically, this means that renal failure is yes and no. So the one that you're going to use as a reference will be the no. No is 0 and 1 is yes. That's what it basically means.
Mhm.
In race, you have 4 categories, so the reference would be white, because if you look at coding, 0 is white, 1 is black, 2 is Hispanic. It's like this.
Mhm.
And then you just go to options. You want the confidence interval. These are basically testing for models. You don't need to go through them. If you do bivariate analysis, your model is always going to be a fit. So Then there are different methods. Enter mean you just put all the variables. Forward conditional mean that you put one variable at a time and then see once the model becomes perfect and doesn't improve anymore, you stop. Backward conditional mean you put all the variables in and you start removing variables until the model doesn't change. So you click OK, get numbers at the end. These are your regression numbers. So you just copy paste these numbers. Then you go and you create an Excel file. Let's see. So and you just paste it like I've pasted here. You paste the ORs, the p-values, the lower confidence, the higher confidence. You put the variables over here. Once you make an Excel file from this data that you got from SPSS, you can name it anything. I've named it here is book 1. Then I'll send you the code. It's going to be an R history file. So then you open that code, it will look like this. You have 4 tabs. You have the console tab, the working tab, and the environment tab. So first thing is you set a working directory. It's already set over here. You just do it like this, set as working directory. Second, you recall your plots. You can just copy paste this and write it down here. So your package is being recalled. So now you can use ggplot. Now you create a data file. So I'm going to create a data directory, which I'm naming as data, and it's being derived from book. Book is the file here. It's book 1 here, so we'll just call it book 1. So we call it book 1. Okay, so I got an error here. Seems I'm forgetting myself how to do stuff. Some more. I'll probably refresh my memory here and then talking, but basically it's just a code line. You have to, once you get the hang of it, it's pretty easy, but you'll forget in a couple of months if you don't do it, but basically you create a data called book. You take it from here, like whatever the name is here, you just use it over here. Then you basically put in the data for creating the figure, and this is the data. So ggplot is your formula, data is the stuff you created over here. And then variable is your first column, or is your second column, low, high confidence. Geometrical point is basically the color of the line, which I've selected as blue. There are different kind of shapes. You can like triangle will be 14, so it's like 15 here. So you can create each number is for different shape. And then intercept is where the line is going to be. So obviously it's usually at 1. IT and Y is the type of line. So it's a solid dot line. It's 2, but they're different codes for different line. And then odds ratio, X lab. This is the X axis. If you want to label it, Y is the, we're going to label it as odd ratio. 95. So that's what we label on odd ratio, but it kind of looks underneath because we put a code, flip code. So it kind of flips the figure. So that's why the X and Y are opposite. And then theme is black and white, and then you can put a title over here. This is the tag, which is a figure, and then you can put a lower index node over here. Once you do this, you'll get a figure. It's going to look somewhere, something like let's see if I have an example of a figure. It's going to look like this.
Mm-hmm.
You can also create this in an Excel. It's much more difficult in Excel, but you can do it in Excel as well. But it's basically a forest plot.
Right.
So that's most of your figure work. I'm probably going to go back. I mean, I've done this R thing as well in my previous lectures, but I probably rough tonight. Anyway, the coding part is something you were kind of asking.
Yes.
So coding is actually pretty straightforward. It's not that complicated. You just need to know your ICD codes. And ICD codes are taken from basically, you can look up the HCAT website and you can take your codes from there. So this is the ICD-9 repository. I'll email you that. I think the ICD-10 repository, they just changed. So it's no longer on my bookmark. It's not working.
Mm-hmm.
But you can always Google them.
Yeah.
The repository here, I like their own repository, which is somewhere hidden in their website, in the HCAT website. You can just look for it. The reason I like this is because Google usually don't tell you when the codes were started, and that can create a mess. So you can see here, it tells you this code begins in 2006, in 2007. So you don't want to use a code that starts in 2007 with a data set from 2001 to 2018. So you have to make sure you know when the code is being used. So that's why I like this. Yes, some of the codes are created after 2018 and we don't even have that data. So then it also tells you when this code ended. So like this code began in 1980 but ended in 1991. So it's no longer used. So that's the benefit of this repository. And then you can easily do like a control F and just find whatever you're. So that's the benefit of it as well. So I'll send you the ICD-9, but I think the ICD-10, it's changed maybe. You can Google and probably find it. So
Right.
yeah, this is it. So I'll probably update my own as well. But that's basically how you find codes. Once you find codes, then there are different ways to code it. So in SPSS, it's always a mathematical equation. So, and all softwares have similar codes. They're not much different. So I'm probably going to email you all these kind of shortcuts that I created. So we'll go through different ways. So one of the codes is called a subtract code. So a subtract code is a group code. So what it really means that you don't, so ICD 910 are structured codes. They're not like individual codes. Let me give you an example of that. So let's go to heart failure, for example. So you have heart failure here. So you can see that all of the heart failures codes still taking its time. I think that's pretty big support. Okay, so I think it's almost done. So heart failure, you can see like all of the heart failures are coded under I11. So you can see here's the heart failure codes actually begin. So you can see all of the heart failures have been coded as I150 and then 1, 2, 221, 222, 223. But essentially every heart failure has 150 in its code. So this is how it's
Mhm.
structure coding. So it's like a tree. It starts with 150, then it branches out. So benefit of this kind of coding is that you can just select all of these codes by just selecting 150. So that's what's called group coding selection. So I can here just do a quick replace my triple stars with I150 and do just replace all, and then my double star with 4. And I've coded a heart failure code in a second. And then I just copy paste this and I'll teach you how to then use it in syntax. But what this means basically is so the double star basically tells you how many variables are you going to choose. So there are 4 variables. So these are the first 4. And triple star is basically the replacement. So I just replaced all of these. So you put your code over here and then how many variables are here, you just put the number over here. If it's 3, you put 3. If it's 4, in this case, you just put 4. And then DX1 is mean diagnosis. It usually runs from DX1 to DX40. For ICD-9, it runs up till DX30, and for ICD-10, it runs up till DX40. So you just then copy paste this stuff, and then you quickly write a syntax. And I probably have a couple of syntax open. This is one syntax open. But let's open a new syntax. And then you just write compute heart failure is equal to, you just paste whatever code you have. You put a dot in the end. This is too lengthy, so you just use enter to kind of shorten the phrase. And then you just write execute at the end, and that's how you create a new variable. Once you run this, you get a new variable CHF, and then you can differentiate CHF, like extract that data file, just how I told you right in the beginning. So that's how you code data. Now this is for diagnosis. You can see here that you can also do procedure. You can do different things. So this is a subtract code, a group code. If you don't want to use a group code, you can use what we call an any code. So an any code would be a single variable, a single code. So you just want to, let's say, select just acute on chronic systolic heart failure. This I5023, you just write I5023 over here, and you have a code ready, which means that if there's any I53 code in any of the variables from diagnosis 1 to diagnosis 30, it will be picked up by SPSS. So this is your primary diagnosis and then the run list up till 30. So anywhere, if somebody has coded heart failure, is going to be picked up. Now this is for ICD-9. ICD-10s have this thing. You can see I10 dash. This is how you differentiate between ICD-9 and 10. ICD-9 would be diagnosed as 1, and ICD-10 would have an ICD-10 in front of it. And if you look at the data set, you'll see the same thing. You can see here, this is ICD-10, ICD-10, and then this is ICD-9. These are ICD-9, ICD-9. That's how you differentiate between them. They're not in order, but that's okay. So So this is an any code for ICD-9, ICD-10. This is a subtract code, a group code. This is also for group coding. This is for procedure. This is also for procedure. And there's numerous ways to write the same code. Like you can write it in at least 20 ways. So for example, this any code can also be written as, I don't know if I have it with one of my very old codings. Let's see if I have very old codings. Yeah, so you can see diagnosis 1 is equal to this, or diagnosis 2 is equal to this. Here, what I'm telling is that if you find 41,000 in diagnosis 1, or if you find it in this, then select that. Underneath, you can see I've done an age code. So here I mean that if somebody is age 55, but is also a female, only select those patients. So you can see an or and an and code can be used different. And means like both of the principles must be satisfied. In or only one of them satisfied is okay. So I'm not asking them to select those cases in which every variable has 4100. I'm saying that if any one of them has 4100, it's fine. And that's where the any codes come from. You just want 41 in any of these variables. So
Right.
I'm trying to say that there are several different ways of writing the same code, but using this is the shortest way to do it. So it's the most refined way I can find. You say that if any has this in any of these variables, you should select it. But it's a mathematical equation, so you can write it different ways. So you will, once you start reading like different syntax I've written, you'll start understanding what it really means. So here, like for example, again, you can use and there's several other syntaxes that I can share with you. For example, missing cases. Let's go back. So this is another syntax. You can see I'm just renaming variables. So you can rename variables. You can put variable labels. So there's several, so it's, you can just Google and find everything basically on Google. But it's basically a mathematical equation. That's what I'm trying to say.
Mm-hmm.
That I wrote the Java score. So what I'm saying that compute if somebody has 875, this is that, so compute means calculate this variable. So name of variable is 875 and age is greater than 75. So this is actually a code for calculating chat bus score. So first I calculate age, variable for age, which is 75 and above, then 65 to 74. So these are the two scores that matter, right? If you're 65 to 74, your score is 1, and if it's above 75, your score is 2. So first I created two variables of age, 75 and greater than 75 and age between 65 and 74. Greater than 75 was calculated by using an equation, age greater than 75. This is the equation. This is the name of the variable. Name of the variable equation. Here I'm saying that the age should be greater than 64 and both conditions need to be satisfied. Age should be less than 75. So it gives you an age between 65 to 74. Once I get my variables, then I just give them score. So I say chat score is equal to 2 into 875. So get 875 variable, it's going to get two numbers. This is peripheral vascular disease, is going to get 1. This is cerebral vascular disease, is going to get 2. This is CHF, is going to get 1. And then I click execute, and I'm going to get a chat score here. So basically it's simple mathematical equation. You can create unlimited numbers of them. You can do different things. You just have to Google stuff or ask me, I can help you if you need to do something. So the key is just get your ICD-9 code first through this website. I'm going to send these links, and then afterwards use either an any code, any, and then just write down the variables you want to search in it. It's going to be any for diagnosis or any for procedures. These are the only two things in NIS: procedure and diagnosis codes. Procedure is for a procedure, diagnosis for a diagnosis. And then you just paste whatever you want. Any is for a single variable, and if you want a group variable, you use this. And then you will have to create like big chunk of variable like codes for that. For example, for PE, there are like several codes, right? So I've copy pasted the codes here, and then I just simply wrote an equation. In the old days, I used to write it like this. This is pretty lengthy, but you can use an any code, which is pretty much a short phrase of doing things. So Ivan, this is a pregnancy state code. So you can see like I've used an any code, so it's pretty neat. And then I've used here a subtract code. And the equation will continue as long as you put R in it. And when you want to stop it at the end of the line, you have to just remove this R and just copy paste this thing. You put a dot at the end. And you have to make sure that the code, it's not too lengthy, because sometimes a syntax they would not allow you to make it a very lengthy. So you have to just like shorten it by just clicking enter, and it's going to get shortened. So coding is pretty straightforward. As long as you just know how to use a couple of codes, you should be able to code things. And ultimately, if you want to go into something competitive like heart failure or cardiology, or you will need research for life. You can't just say, oh, I'm just going to do research for fellowship, because even after fellowship, you need research. So I would say just learn it once and just be good at one thing. Like just learn basic analysis. You can learn it in a couple of hours, and just once you start doing it, you're going to get good at it.
Right.
So there are different books available for coding. It's pretty straightforward once you start using it. You do forget very quickly, but you can always refresh your memory. It's very straightforward, to be honest. Coding is very straightforward. It's not that difficult. It's boring, but not difficult. Everything has a method to it, and once you start doing it, and in future, it's possible that they might not accept any other analysis apart from R, because R has a good like universal accessibility, and you create a history file while you're doing like anything. So the history file you can then share with the people who are looking at your analysis, and they can check your work or duplicate it. So what I would like you to do is work on PE, because PE, nobody has done a lot of work. So you can, I'm going to share this data set file with you. You can compare the trends of PE, like just compare male and females, and then just make a table between male and female, see what is the difference between outcomes, make a baseline table, then make a outcome table. I'm going to kind of send you share with you a file like what I've done with a male-female research comparison, and you can simply use that as a template, but just use male and female, compare their outcomes, then make a line graph to see trends over the years. So for example, let's see. Where have I done? what I do is I kind of make two tables. The first table is baseline characters, like this. And then the second table is usually the outcomes table, um, like this. And then the third, afterwards, I just make figures on Excel. So basically, you can just use Excel to make figures. And Excel, I think, is the most easier software to learn, and you're going to need it in the future anyway. So it's better you just stick to Excel. That's what I think. You can also make all your images through R. I used to make them through R, but in Excel, you can send the images to somebody else and they can kind of change it according to whatever they want it to. So in R, it's not everybody is comfortable with it. You can make the, if you don't want to use R, you can make your, actually your forest plots using Excel. I can send you that template, but you're going to get confused. It's pretty much just more difficult in my. So this is like I'm using Excel to create a line graph, but this is a forest plot, but this is much more complicated in my opinion. You're going to get confused if you try using this. I think R is easier for this. If you want to learn more about R, there are different books. I can email them to you. But I would say work on PE, just check what work has been done. From what I gather, not a lot of work has been done on pulmonary embolism. It's kind of like an area which is not a lot cardiology, because mostly pulmonary medicine. But nowadays it's the new field in cardiology, because pulmonary medicine, they've kind of washed their hands. They don't want to do PE, they don't want to touch the patient. So now a lot of hospitals are making like P response team, which is completely been led by intervention cardiology. So this is like a new field and no work has been done in this area. So I think this is something you can just look into, see what has been done, and then you can work on PE. I can just share the data set with you and you can do a lot of work. You can do age, you can do race, you can look at trends, then you can look at end-stage renal disease. You can even see the procedures. I think there is a procedure code for catheter directed thrombolysis. There's also a code for systemic thrombolysis. You can compare all of this stuff. So I would just select one topic and then do all of my work on one topic. The benefit is that you can get renowned in a single topic. So that's how I would do, and you can do it very fast. So if you don't want PE, you want to try something else, whatever topic you want, just let me know. I can get the data out for you. But you'd have to kind of refine the data set yourself. So yeah, that's pretty much it.
Right. Yeah, I had a question about the coding that you were doing. When you do the coding, what does it get? Does it give you the data set in the end? Like if you use all ICD codes for heart failure, will it pull all the patients who had heart failure and then you can do your analysis on it?
So it depends what are you doing. If you're just writing a compute code like here, you're creating a variable inside the data set. So it's going to appear inside the data set. So this is your